optimizing reactive power dispatch in electrical networks using a hybrid artificial rabbits and gradient-based optimization. Dr. Francisco J. Ruiz-Rodríguez. The optimal reactive power dispatch problem is a critical factor in maintaining the safe and efficient operation of electric networks. Due to its mixed variable nonlinear nature, addressing this problem requires an appropriate optimization algorithm. In this study, a novel approach based on the combination of artificial rabbits optimization and gradient-based optimization algorithms was proposed to solve the ORPD problem in electric networks. The performance of the proposed AROGBO algorithm were verified on 7 numerical optimization test functions. To evaluate the effectiveness of this hybrid AROGBO technique, standard IEE 30, IEE 57 bus, and IEE 118 bus test systems were employed, with 2 objective functions tested for each system: minimum total power loss and minimum total voltage deviations. The AROGBO, ARO, and GBO algorithms were utilized in each case to determine the optimal values of the generator voltage, transformer tap changer positions, and reactive power compensation values. A comprehensive comparison was made between the results obtained from the hybrid ARO-GBO algorithm, standard ARO and GBO algorithms, and other metaheuristic optimization techniques. The simulation attainments verify the accuracy and stability of the proposed ARO-GBO methodology in solving the ORPD problem.